Hey students, in this video I'm going to go over the domain and range of quadratic functions. So just to review, domain stands for all x values and range stands for all y values. So as soon as you think of domain, picture the word or the letter x and then the direction of movement left to right. And then when you hear range, picture the letter y and the direction of movement is up and down. Now I know we mentioned in the previous video that there are different forms for quadratic functions, but they all will end up looking like a U. So you will always have a U-shaped graph. The only difference is that a value in the front will tell you how it opens. It either opens up or down, but all of the graphs will look like a U. So therefore, your domain for all these graphs will always be the set notation, set builder notation of x such that x is an element of all real numbers, and the interval notation will always be negative infinity to positive infinity because it's written left to right. So all of them look like a U, whether it's opening up or down, and it's going left and right forever, which means it's all real numbers. What will be different is the range. So similar to the previous unit, you do have to find whether you have a maximum or minimum. So if the A is positive, it's opening up, which means you will have a minimum. If you have a minimum, that means your y values are going to only be greater than that minimum. So your annotation for set builder notation will state that the y values are greater than a value. That value that you use is actually the k value in your vertex. So just keep that in mind. The interval notation for this will be the minimum, comma, maximum. It still follows that format of minimum, comma, maximum. Your minimum is your lowest, your maximum is your highest. Because the graph is opening up, it's going to go up forever, which means you will have that infinity as your max. Because the graph is turning at the bottom, creating that minimum, that is where you specify what is the lowest value. So the first value will be a number, followed by infinity, bracket, parentheses. So bracket means it's touching the number and stopping there. And the parentheses means it's just approaching it and never touching it. If you have an A that is negative, you have a graph opening down, which just switches everything up. Now you have a maximum. And that maximum means that you only have values that are lower than that maximum. So your notation, your set builder notation states that by having the less than. That less than k means k, the highest y value you have on the vertex. And then your interval notation is opposite because you're still writing it as minimum, comma, maximum. But now your minimum is your negative infinity. It's going to go down forever, so negative infinity. And then your maximum is the number where it's stopping it. So it's just, again, understanding carefully how to write these notations. All right, so we're going to go over these problems right here. This graph is already graphed for you, so you can just analyze it by looking at it. You can also identify, even if the graph wasn't given, that this is in vertex form. And when you have the vertex form, you can identify the vertex by the letters of h and k. So it's x minus h plus k. X minus a number, x minus h, that means your h is 4 and your k is 3. So with that in mind, notice that that is correct, 4 to the right, 3 up. Now we can identify that our minimum is that k value, that 3. So that is your minimum. And the only thing that it affects is the range because, again, the domain is going left and right, and this graph is going left and right forever. So x such that x is an element of all real numbers, and the interval notation is negative infinity to positive infinity. The range, we're looking at having a minimum, which means anything higher than that 3. So y is greater than or equal to 3. And then the interval notation, we're still writing as minimum comma maximum. Minimum meaning the lowest, maximum the highest. The lowest is your minimum, so that's 3, comma. Your highest is infinity, it's going up forever. So parentheses on infinity, bracket on 3. Okay, let's try another one. This one is written in standard form. And standard form is just simply giving you the y-intercept of 3. But it's not really helping you with domain and range. So in this case, we'll just go based on the graph. This graph is opening down. So left and right is going left forever, right forever. So we're still going to do x such that x is an element of all real numbers. And the interval notations is still negative infinity to positive infinity. It's the range that is different every time. So for here, we identify our vertex or our maximum value, in this case, of 4. And then we notice that the highest is 4 and the lowest is going down forever, so negative infinity. So these are the values we're going to use for interval notation. As far as set builder notation, you're just specifying that you have a maximum of 4 and anything lower. There's nothing higher than 4, anything lower. So we're going to say y is less than or equal to 4 for the set builder notation. And then interval notation, you want to follow the template of minimum comma maximum. Minimum meaning the lowest, maximum the highest. Minimum is negative infinity. Maximum is 4, bracket around the 4, parentheses around the negative infinity. For these next two problems, we don't have a graph, but we still could analyze it or graph it in the calculator. This is in vertex form though, so I believe we can identify this just by looking. Your a value is negative. When a is negative, we can identify it as being upside down like this. And that means you have a maximum. So because we have a maximum, we're going to have values that are lower than whatever highest value that is. It is in vertex form, so if we can identify the vertex just by looking at it, should be x minus a number. So x plus 3 means x minus negative 3, and then plus 6. So x minus negative 3 and 6. So your k value is 6, which means the highest it goes is 6. We can write our notation already saying that we're looking at values that are less than or equal to 6. We can also visualize that if we write it in minimum comma maximum, the lowest this graph will go is negative infinity because it's opening down. So negative infinity to the 6, because 6 is the maximum. Bracket in parentheses around that. And then we can write the domain to being, again, x such that x is an element of all real numbers, and negative infinity, positive infinity. That's not going to change. It's a quadratic function, so it's always going to be that for domain. For the last one, or actually let me graph that just so you can verify that it is what we wrote. I'm going to move this a little bit right here. Okay, so we're going to have negative 1/2 x in parentheses plus 3 squared plus 6. So this graph has domain and range left forever and right forever, so negative infinity, positive infinity. And then as far as tracing it, it is going to say maximum at negative 3, 6, meaning 6 is the highest that it'll go. So it just backs up our range right here. All right, for the next one, this is an intercept form. So because this is an intercept form, we just identify intercepts from these two values. Should be x minus a number. X plus 1 is x minus negative 1. So that means negative 1, 0 is an x-intercept. And x minus 2, x minus q. So that means 2 is the other x-intercept. If we did not have a calculator and you had to identify the turning point for this, you first need to analyze that the a value is positive. That means if it's positive, the graph is opening up. So if it's opening up, you have a minimum, which means that you are looking at values that are greater than a number. And you're looking at writing a minimum value first, then a maximum value. Maximum will be positive infinity because it goes up forever. So we just need to worry about finding that lowest value. Again, this is without calculator. So you could find, like, where is the line at in between these two x-intercepts, but you cannot find the y value for that vertex. So let's just graph it in the calculator to find it. So I'm going to clear it and write 3 x plus 1 and x minus 2. So then we trace minimum, it says 0.5, comma negative 6.75. So that means the lowest value that this graph goes on the y values is negative 6.75. So y values that are greater than negative 6.75. And the notation is negative 6.75 all the way to infinity. Your domain and range, your domain will never change, so it's still going left and right forever. So x such that x is an element of all real numbers, and then negative infinity to positive infinity. It's just that range that you guys got to practice on identifying based on minimums or maximums. Okay, hope this video helps you.